Hi friends, in this video we see type 4 and type 5 ordinary differential equations. Here type 4 is very simple only. Let us see what is the form of type 4 ordinary differential equation. Here f of x will be in the form of e power axx. So what is f of x? So what is that? If you want to know that, please refer my video on type 1. Then only you can continue this type 4, right? So please come in the order of type 1, 2, 3. Then only we can solve type 4 problem. So I request you to see all the videos before you watch this video. So if f of x is equal to e power ax into x format, where x is either sin x, sin ax or cos ax or x of x power n, then how to find particular integral? Then particular integral is given by 1 by pi of the e power ax into x, that is equal to e power ax. This e power a should come to the left hand side, and d must be replaced by d plus a. That's what this method, right? So when we solve the problem, you will understand. So this d must be replaced by d plus a. If e power minus, it must be replaced by d minus a, and this should come out, right? So after that, we know how to solve this problem, right? So here, if it is e power x type 1, sin x format, it is type 2, or x power n type 3. Like that, you can solve it by using any method. So this is the way type 4 works. Type 5 will be in the format where f of x will be in the format of x power n sin ax. Instead of e power x, here it will be in x power n sin ax or x power n cos ax, right? So what can we do? We know that sin ax is nothing but it's imaginary part of e power iax, right? Because we know, you just leave it, you just see here. We know that e power iax is equal to cos ax plus I sin ax. So I can write cos ax as real part of e power iax, and sin ax as imaginary part of e power iax, right? So suppose if your problem has x 1 by pi of d into x power n sin ax or x power n cos ax, right? You see 1 by pi of d x power n sin ax I can write as sin ax I can write as imaginary part of e power iax, right? And we know if it is a e power iax, then I should replace d by d plus ia, type 4, right? It is coming from type 4, right? So here what I did is, this is nothing but imaginary part of e power iax, right? So 1 by pi of d x of n into imaginary part of e power iax. Since x of n e power iax format, e power I can replace by d by d plus ia and take it outside. That's what I did here. So now it becomes type 4. If it is cos, I make it as a real part of e power ix divided by 1 by pi of d plus ia x power n, right? So this is a simple method. When we solve the problem, you will understand how to proceed, right? So let me take one example. The first example for type 4 is d squared minus 2d plus 1 into y, that is equal to e power x into 3x squared minus 2. You see that it is type 4 because e power ax into some x. It is e power ax format where a is 1. So it is type 4. So first, as usual, we find auxiliary equation. Auxiliary equation is m squared minus 2m plus 1. Replace d by m and replace f of x by 0. So it will be equal to m is equal to 1 comma 1. So two real and equal roots. So complementary function or auxiliary. This is auxiliary equation. Now complementary function. So CF is equal to, what happens? Two equal roots. So ax plus b into e power x. Next, particular integral. Particular integral is given by 1 by pi of d. Pi of d can be obtained like this. So I write directly pi of d. This is d squared minus 2d plus 1. So I write as d minus 1 whole square, right, into e power x into 3x squared minus 2. What I told, whenever you have a e power a format, replace d by d plus a and bring that side. Here a is 1. So e power x d by d plus 1, d plus 1 minus 1 square, and 3x squared minus 2. Here it will be equal to e power x divided by 1 by d squared into 3x squared minus 2. 1 by d squared is nothing but 2 times integration. So e power x, right? First time if you integrate, what will happen? It is only, let us take 1 by d. One time I integrate. So I directly integrate 3x squared. If I integrate 3x cube, 3x squared means 3x cube by 3, fine, and minus 2x, right? This will be cancelled. Okay. 3x cube by 3, this will be cancelled. Second time I integrate, what will happen? E power x, x power 4 by 4 minus 2x squared by 2, 2 cancel. So e power x, x power 4 by 4 minus x squared. This is what our particular integral. So y is equal to CF. CF is nothing but ax plus b e power x plus pi is e power x, x power 4 divided by 4 minus x squared. Simple problem, right? So this is what my answer. Let us solve one more problem for type 4. E plus 1 whole square y is equal to e power minus x cos x. You see it is e power x into x format, so type 4. First we write auxiliary equation, replace d by m, so and make it f of x is equal to 0. Right hand side is f of x, that is equal to 0. If you simplify, what you get is m is equal to minus 1 minus 1. So to a real and equal root, so CF is equal to ax plus b into e power minus x, mx, x, m is 1, so this is what my CF. pi is equal to 1 by pi of d is nothing but d plus 1 whole square e power minus x cos x. Whenever we have e power into cos, replace d by d minus 1, here a is equal to minus 1 square, here take e power minus x outside, cos x, fine. So what happens? E power minus x divided by cos x. So 1 by d squared is 2 times integration. So first time when you integrate, what I get is 1 by d. Cos x means cos x integration sin x. Second time 1 by d is 1 time integration. First time integration, so I took 1d outside, 1d out. So this is remaining 1d is there. So if I integrate sin x, it will become minus cos. This is what my pi. So what is my y? My y is equal to CF plus pi. So ax plus b into e power minus x minus e power minus. This is what pi cos x. Fine. So this is also one of the simplest problem. I hope you understand how to solve type 4 integration. Now I give example for type 5. How can we proceed type 5? The question is d squared minus 2d plus 1 into y is equal to x sin x. Now it is x power n into sin format, right? Not e power, x power n. So x power n is equal to 1. So it is type 5. Right? How to proceed? As usual, first you find the auxiliary equation. M squared minus 2m plus 1 is equal to 0. This indicates m is equal to 1 comma 1. Right? So see, complementary function is equal to a plus b. Okay, a plus b e power x. Right? So this is what complement. Pa, that is equal to 1 by pi of d. Pi of d is d squared minus 2d plus 1 into x sin x. Sin means it is imaginary part of e power ix. So I write as imaginary part of 1 by d squared minus 2d plus 1 x into cos x plus I sin x. Yes or no? Because they are sin x. What is imaginary part of this whole equation? Imaginary part of whole equation is 1 by d squared minus 2d plus 1x into sin x. That's what they have written here. Real part is 1 by d squared minus 2d plus 1x into cos x. So since it the question is sin x, I write as like this. Right? Okay. Now that is imaginary part of 1 by d squared minus 2d plus 1 x into this is e power ix. Fine. So imaginary part. Whenever x into e power I format, I means replace d by d plus I and I bring this e power I left hand side. E power ix 1 by d plus I squared minus 2 into d plus I plus 1 into x. Fine? Okay. So now what happens? Imaginary part of e power ix. Right? So I simplify this. It will be like d squared minus 2 into 1 minus d minus 2i into x. Okay. So I write as imaginary of e power ix 1 by I take minus 2i outside because I want it, and then I solve this problem in the type 3 mode, right? So 1 plus x binomial expression type 3 mode, hope you remember. So I take minus 2i outside, so it will become 1 minus d squared minus 2 1 minus I to d divided by 2i into x. Fine. So when you simplify imaginary part of e power ix minus 2i, take it outside, 1 minus, it will become 1 minus d squared minus 2 into 1 minus I into d divided by 2i. I bring numerator to denominator, so it is power minus 1. Fine. Into x. So then we go for binomial expression 1 minus x whole power minus 1. So if you simplify, what you get is imaginary part of e power ix into I by 2 1 plus I d divided by 2i. Then it will go into x. So what do you do? Imaginary part of e power ix I by 2. This is 1 into x. Differentiation of x is 1, so 1 plus I, right? So do that, you get like this. Then hereafter simple simplification only, right? Imaginary part of 1 by 2, then e power ix I write as cos ix plus I sin x, so it will be I cos x. E power ix I write as cos ix plus I sin x, multiply with I, so it will be I cos x minus sin x x plus 1 plus I, that is equal to imaginary part of, what is the imaginary part of this one? This is equal to 1 by 2 x cos x plus 1 by 2 cos x minus 1 by 2 sin x. This is what imaginary part. So this implies y is equal to cf plus pi. Fine. So already we know cf is a plus b x e power x. Now pi is 1 by 2 x cos x plus 1 by 2 cos x minus 1 by 2 sin x. But don't worry, they won't ask this much big problem. The problem will be very simple in the competitive exam, right? First you understand what is the logic, that's enough, right? I hope you understand everything. If you have any doubt, please ask me in comment section, I will clarify. Thank you.